Hello viewers, I am Kausalya. Today we are going to solve problem number 7 in time response analysis. And the problem is a unity feedback control system is characterized by the following open loop transfer function. This is the function. Determine its transient response for unit step input and sketch the response. Evaluate the maximum overshoot and the corresponding peak time. So here an open loop transfer function is given and the type of feedback is mentioned as unity feedback. As I already said, whenever a unity feedback is simply mentioned, we should consider the feedback as negative feedback, right? Then they are asked to find the transient response for unit step input. That is, transient response is, in other words, output response of the system. We are asked to find the C of t and sketch the response. We are also asked to draw it. Evaluate the maximum overshoot. That is, we are asked to find what is the value of maximum overshoot and the peak time. Right. So the first step is we need to calculate the closed loop transfer function. So as we all know, this is our given g of s and the type of feedback is unity feedback. And the closed loop transfer function, as we all know, output by input is equal to g of s divided by 1 plus g of s into h of s. Now we are going to substitute the value of g of s and h of s respectively in this formula. So when you substitute the values, here the type of feedback is unity feedback. So the value of h of s becomes 1 here. So this is g of s divided by 1 plus again g of s multiplied by h of s. Right. And the next thing, we are going to take LCM. So when you take LCM, automatically this s into s plus 0.6 term get multiplied with 1. So s into s plus 0.6 plus 0.4 s plus 1, the whole thing divided by s into s plus 0.6. Again, both the denominator terms are same, so they cancel each other. And finally, we are getting an expression as 0.4 s plus 1, the whole divided by s into s square plus 0.6 s plus 0.4 s plus 1. Right. Here we are having two s terms, so we can add these two terms. So 0.6 plus 0.4, we all know it is equal to 1. So we are getting the final expression as s square plus s plus 1. So we are getting the expression as C of s by R of s is equal to 0.4 s plus 1 divided by s square plus s plus 1. Right. So in the problem they had given, the type of input is unit step input. We are asked to calculate the output response. So for unit step input, the value of R of s is 1 by s. So from this thing, we are moving this R of s to the right hand side. So C of s is equal to R of s into this term. So the value of R of s for unit step input is 1 by s. So just substitute the value of 1 by s in the place of R of s. As usual, by partial fraction, we need to simplify this equation. So, by partial fraction, here, this is our equation and this equation has two denominator terms. Okay, one is normal s term and another one is a quadratic equation. So, we are splitting the term as a by s plus, since this is a quadratic equation, we are writing it as bs plus c. Right. So again, this quadratic equation, we cannot find the roots directly because the roots of this type of equation will be of complex conjugate type. So only we are writing, for solving this equations in partial fraction, we are writing as bs plus c. Right. So keep this one in your mind. Then next thing, we are taking LCM. So here, when you take LCM, that is just cross multiplying. So a into s square plus s plus 1 plus again s into bs plus c, the whole thing divided by s into s square plus s plus 1. So when you compare these two equations, both the denominator terms are same, so they cancel each other and finally we are having an equation like this. 0.4 s plus 1, which is equal to, just multiply this a with the terms inside the bracket. So when you multiply as square plus as so here just we are multiplying the terms. So a into s square, a into s, as plus a into 1, a plus s into bs, bs square plus s into c, cs. Right. Now just we are going to compare the terms on both the sides. So when you compare, first we are going to equate constants. Here 1 is a constant and here a is a constant. So a is equal to 1. And the next thing is we are going to equate coefficient of s. So when you equate coefficient of s, here the coefficient of s is 0.4 on the left hand side. And the coefficient of s on the right hand side is, here I am having a and here I am having c. Therefore 0.4 is equal to a plus c, and we know the value of a as 1. So just substitute the values here, and finally we are getting the value of c as minus 0.6. Right. And the next thing is equating coefficient of s square. Here there are no s square terms, so it is 0. And in right hand side we are having a square plus b square. That is when the coefficients are a plus b. So 0 equal to a plus b, and the value of a we already know. So when you substitute here, the value of b is equal to minus 1. Right. Now the next step is we are going to substitute the values of a, b and c in our equation number 1. Okay, this is our equation number 1. So here just I am substituting the values. That is 1 by s. In the place of a it is 1, and in the place of b it is minus 1. So minus 1 into s becomes minus s, and the value of c is minus 0.6. So minus 0.6 divided by this denominator term. Since both the terms have negative sign, I am taking this negative sign outside. So the remaining terms will be s plus 0.6 divided by s square plus s plus 1. And the next step is, I am splitting this s plus 0.6 as s plus 0.5 plus 0.1, and the entire thing divided by, again I am splitting this 1 as 0.25 and 0.75. Right. Since we are having 0.5 here, the 0.5 square will be 0.25, right? So I am splitting this 1 as 0.25 and 0.75. And the next step is, again I am splitting these terms, that is s plus 0.5 divided by s square plus s plus 0.25 plus 0.75. Again for this 0.1, minus into plus, minus 0.1 divided by this denominator term. So when you look at this denominator term, that is s square plus s plus 0.25 can be written as s plus 0.5 the whole square. See, a square, that is s square plus b square, 0.5 whole square will be 0.25 plus 2ab will be again s here. So s square plus s plus 0.25 can be rewritten as s plus 0.5 the whole square plus this 0.75 as such, minus again 0.1 divided by s plus 0.5 the whole square plus 0.75. Right. So when you look at this equation, when you take inverse Laplace transform, that is an answer for 1 by s, and we can also take inverse Laplace transform for this expression. Whereas for our third term, here we can't apply inverse Laplace transform directly. So for applying inverse Laplace transform, here I am having 0.75, right? So I am multiplying this expression by multiplying and dividing this expression by square root of 0.75. You see here root of 0.75 is multiplied as well as divided. Now when you take inverse Laplace transformation, here inverse Laplace transformation of 1 by s is 1, and for this expression s plus 0.5, so this becomes e power minus 0.5t into here cos of square root of 0.75t. This is the formula. Right, minus again this 0.1 divided by root of 0.75 remains the same, and when you take inverse Laplace transformation for this expression, that becomes e power minus 0.5t into sine of square root of 0.75t. Now in this expression we are having minus e power minus 0.5t term as common. So I am taking these two terms commonly outside. So when you take this term outside, the remaining terms are cos of square root of 0.75t plus 0.1 by square root of 0.75 into sine of square root of 0.75t. So this is our final output response of the system or transient response of the system. The next thing is we are asked to sketch the response. So this is the output response. So when you look at this expression, you see 1 minus e power minus 0.5t, that is an exponential term with a negative sign. This means that this says that this is a decaying exponential term, right? So here this is your typical output response, that is initially it goes high, the value is high. Since it is decaying exponential component, automatically the value gets reduced and finally it will be settled down, right? Then the second part of the problem is they are asked to find maximum peak overshoot and peak time. So in order to calculate the peak overshoot and peak time, we are comparing the standard second order equation, that is characteristic equation, with the standard form we get from the problem. S square plus 2 zeta omega ns plus omega n square is equal to S square plus S plus 1. So when you compare, omega n square is equal to 1 here and 2 zeta omega n is equal to 1 again, right? So from this equation, omega n is equal to 1. So just substitute the value of omega n equal to 1 here. So when you substitute, finally the value of zeta will be equal to 1 by 2, which is nothing but 0.5. So we all know the formula. Percentage maximum overshoot is e power minus zeta pi divided by root of 1 minus zeta square into 100. So we know the value of zeta as 0.5. So just substitute here. When you substitute, finally you are getting the answer as 16.3%, right? And the next thing is peak time. This is also a direct formula substitution. So peak time is pi by omega d. So which is equal to pi by omega n into root of 1 minus zeta square. So we know the value of omega n. Here you see the omega n is 1. So and we also know the value of zeta. So just directly substitute the values and finally we are getting the answer as 3.628 second. So again look at the graph here. So here what is the value of maximum overshoot? Here the value of maximum overshoot is 1.163, right? And the value of peak time to reach that maximum overshoot is 3.628 seconds. So this is the typical output response for the given problem. Hope you people understand well. Thank you.